Okay, in this example, this one is not in your book. I thought example 3 in the book was not very helpful, so I came up with a different one for you guys that will hopefully help you later on. So what I want to do is I want to write a 2-column proof, and I want to show that lines or segments WY is parallel to XZ. So I got my given written down. WX is parallel to YZ. So I'm going to actually outline those a little bit, because this is what I already know. Here's YZ, here is WX. I know that those are parallel. And I know angles are going to be congruent, or some of them might add to 180, based on the fact that my lines are going to be parallel. There are 2 ways to do this proof. I'm going to use alternate interior angles to do this. What you guys might want to try and do is work through this proof again using consecutive interior angles. Just to give you another shot or another idea of how to do this proof. So there's more than one way to do this and get to the final result. Okay, I'm going to look at this line, WY, being my transversal. Well, that is my transversal. I'm looking at angles 1 and 3. Just going to extend those lines a little bit. I'm looking at angles 1 and 3, and I know that those angles are congruent from this part of the given. Since those lines are parallel, angles 1 and 3 are alternate interior angles. And if lines are parallel, then I know alternate interior angles are congruent. So I'm going to put angle 1 is congruent to angle 3 by alternate interior angles. Next, I want to use my given, the other part of my given, and the part in yellow here. Well, I have angle 2 is congruent to angle 3, and I have angle 1 is congruent to angle 3, which means that angle 1 should be congruent to angle 2. There's 2 reasons that I'll accept for this substitution or transitive. Technically, it's really a transitive property if you kind of switch this around. For our purposes, since we use this one more often than not, I'm just going to call it substitution, even though technically it is the transitive property. And then we're going to go back up to my picture, and I'm actually going to erase a lot of these lines to hopefully help us understand what's going on next. Well, we're actually there. We've actually got to the end of our proof now. I'm trying to show that WY, this one, is parallel to this line. This one is going to be my transversal. There's a relationship between angles 1 and 2. Might be kind of difficult to see, but those are corresponding angles. And since I have corresponding angles being congruent, I know that my lines now are going to be parallel. So I can actually state my last part for what I'm trying to prove. I can write down WY is parallel to XZ. And I know this because corresponding angles are congruent. But I went backwards. It's not just corresponding angles. This is actually the converse, because I went from angles being congruent to my lines being parallel. So I'm going to write converse of corresponding angles. Again, I would try and rework that proof, and I would try and use consecutive interior angles. That will also prove that those 2 lines are parallel.